Next question, I'm going to factor this into x minus 2x plus 2 first, just because I recognize it factors really easily. And then x minus 3x plus 3. Then I can answer these questions again. Vertical asymptotes occur at zeros at the bottom, 3 and negative 3. Horizontal asymptote, since it's a ratio of the leading coefficients, which in this case is 1. And then the x-intercepts. X-intercepts occur once again where y is 0, so that's where the top is 0, which is 2 and negative 2. And y-intercepts occur where x is 0, so plug in 0 for x and you get negative 2 times 2 over negative 3 times 3, which is negative 4 over negative 9, which is 4 over 9. Same question, then different function. So vertical asymptotes occur at zeros at the bottom, which would be 7/3. Horizontal asymptotes are a ratio of the leading coefficients when the exponent's the same, when the degree is the same, which would be 1. X-intercepts occur where y is 0, so set y equal to 0, and you're basically solving 3x plus 1. Subtract 1, you get negative 1/3. And then the y-intercepts occur where x is 0, and so plug in 0 for x and you get 1 over negative 7. This is supposed to be negative 1/3. The domain then, the domain is all real numbers except for where the bottom is 0. So you'd say negative infinity all the way up to 7/3, that vertical asymptote, and then as well as from 7/3 all the way up to positive infinity. Okay, the next question gives us two functions, this rational function and this linear function, and it asks us to answer these following questions. So go ahead and graph it, and what you see is that this function, the rational function, is the blue one. The green one's the line, and what you'll notice is they have similar end behavior. So if you look at, if you scroll out, you'll notice that as the x values get bigger or smaller, the blue function basically becomes the green function. And we'll look at that. Basically, the reason why that is because if you do the long division for this rational function, you get this line right here. So what that means is, when x is really, really big, the blue function becomes the line. All right. So that's all we have to say there is A. They have similar end behavior. They obviously don't have the same x-intercepts. If you look at this. They also, don't have similar asymptotes because the blue function has vertical asymptotes that the green one doesn't have, obviously. So the only thing that's the same is the end behavior. So let's do one where we actually find the slant asymptote. So what we need to do is do the long division. You could actually do synthetic division in this case because it's a linear factor, but long division is something we probably need to practice a little bit. So this is 10x squared minus 4x minus 6. So what do we put up here to multiply by 5x to get 10x squared? That'd be 2x. 2x times 5x is 10x squared. 2x times negative 2 is a negative 4x. And when you subtract, you get no remainder. Or nothing there. So drop the negative 6. So what do I need to multiply 5x by to get negative 6? Well, I guess 1 is the best I can do. Or negative 1. When I multiply by negative 1, I'm sorry, there's nothing. So my remainder is negative 6. So this is negative 6 over then the divisor 5x minus 2. So that's my remainder. So basically what that means is this function right here equals, it's the same exact thing as 2x minus 6 over 5x minus 2. So if you do the division, you get 2x minus 6 over. So basically what that means then is as x gets big, which is going to happen, x is going to get big here, this quantity is going to go to 0. So as x gets big or small, this thing drops off, and you just have this line 2x. So when they want the slant asymptote, you just take the quotient when you do the long division right here. That's the slant asymptote. So let me graph that real quick and show you that. So there's the original function. We did the division. We know that eventually it becomes this line 2 to the x, and you can see that as x gets big, you can see that this part drops off. The remainder, is over the divisor, so that ends up being 0, and you end up with just 2x, which is exactly what we see happening. All right, next problem gives us this rational function and it wants to estimate the one-sided limits. So what this is saying is basically what does the y value of the function do as we go towards 2 from the right? So if you look at that on decimals, what you see is when we go from 2 to the right, this thing goes to positive infinity. So we would say just infinity there. Okay? Now the next thing is when we go from, what does the y value do when we go towards 2 from the left? So when we go towards 2 from the left, it goes down to negative infinity. So we would say negative infinity. All right, next problem wants the x-intercept. First, I like to factor these whenever I can factor them. The top actually does factor. There's a pattern for the difference of two cubes, but we can actually get away without factoring this if we don't want to use that in the numerator. But the bottom does factor. Bottom factor, if we pull out a negative x squared, we'll have x plus 64 in the bottom. So that helps us find some things here. The x-intercepts, keep in mind, on a graph is where y is 0, so that's where the top is 0. And actually, so if you set x cubed minus 64, you add 64 and then take the cube root, you get 4. So that's the one spot where we have an x-intercept and the top is 0. And then the y-intercepts occur where x is 0. So if you plug in 0 for x, you get negative 64 over 0. That's undefined, so there's none. The vertical asymptotes occur at zeros at the bottom, so that'd be 0 and negative 64. And then horizontal asymptotes, since the exponents are the same in the top and the bottom, then those are ratios of the leading coefficients, so that'd be 1 over negative 1, which is just negative 1. All right, some more limit practice then for problem 13. So we want to know what happens if the y value of the function as x goes to positive infinity. Well, it looks like it approaches this number 3. A little hard to see that, but that's 3. So we would say that the y value goes to 3 as x gets big. As x gets really small, the y value also goes to 3. As x approaches 1 from the right, this goes up to positive infinity. So I would just say infinity. And as x goes towards 1 from the left, it goes up to infinity as well. Okay, next question wants to know about the horizontal asymptote. Once again, on the formula sheet, those occur at, well, we have to know what the degree is in the top and the bottom. So in the top we have second degree, in the bottom we have second degree. Since it's the same degree, then we have to do a ratio of the leading coefficients. So I actually have to factor the top out a little bit and put it in standard form. But I know that negative x times negative 2x gives positive 2x squared. That's going to be the leading term of the numerator when I FOIL it out and reorder it. So all I have to do is look at that in comparison to what's in the bottom, and I know it's 2/3. Okay, you can do some of these limits without graphing them as well. If you look at this first function here, think about sticking in a really big negative number, you know, like negative 1,000. All right, well, any big negative number to an even power is a positive, so that's a really big positive number. Like, I'm just making up something, but it's, you know, just some huge positive number. So you can tell that as t keeps getting smaller, this thing's going to go off to positive infinity. So I would say positive infinity. You can kind of reason with it by saying, what would happen if I stuck in a really big negative number? Well, it gives me a really big positive number, which means this thing's going off to infinity. You can do the same thing with the next one then. What happens when you stick in a huge positive number? And for this one, this is really 6 over y to the 4th. So when you stick in a really big positive number, you get a huge number in the bottom. So 6 over some huge number, let's look at. I mean, think about it. That's going to 0. All right, so we would just say that's going to be 0.